Nitric acid production also releases nitrogen oxide as a waste substance, which is then carried by the wind to the atmosphere. Eventually, the gas dissolves in the rain and causes the rain to be acidic. The acidic precipitation falls onto the earth, and if it flows into the river, can cause harm to aquatic lives. Now, let's have a look at the definition of acid rain. Acid rain involves all types of precipitation that is more acidic than normal water. The nitrogen oxide released by the industrial process reacts with oxygen in the atmosphere to form nitrogen dioxide. Later, nitrogen dioxide reacts with water vapor to form nitric acid and nitrous acid. However, in this reaction, the major product being formed is nitric acid. So, how does the acid rain affect aquatic lives? Well, normal pH of lakes and rivers ranges from 6 to 8. However, when acid rain mixes with the water in lakes and rivers, the pH value drops into a range of 5 and below. When water contains too much acid, it will no longer be able to buffer the acid rain. When water loses its ability to buffer acid, some species in the ecosystem will die. Without some of the species that predators feed on, predators will also die. This is how acid rain affects aquatic lives. This chart represents aquatic animals and their abilities to survive under acidic water conditions, ranging from a pH of 6.5 to a pH of 4. The blue part of the chart shows that as pH decreases, less animals can survive. Since the ecosystem takes a long time to recover, it is important to manage the industrial waste from nitric acid production wisely. This can be done by using molecular sieve or carrying out extended absorption or catalytic purification. Molecular sieve can be used in nitric acid plants with high pressure absorption where nitrogen dioxide is absorbed from the waste gas at an ambient temperature. A molecular sieve is a sodium-based crystal structure in forms of pellets and spheres. It works by absorbing kinetic diameter which is less than 10 angstrom and exclude larger size. With this, it is able to separate nitrogen gas from oxygen gas. On the other hand, in catalytic purification method, the nitric oxide produced is reacted with excess ammonia to form nitrogen and water. For this purpose, catalysts are used. Examples of catalysts used are such as vanadium pentoxide, iron chromium oxide mixture, or zeolite. Extended absorption can also be used to reduce nitrogen oxide emission by treating the waste gas either with sodium hydroxide or ammonia. This way, nitrogen oxide and nitrogen dioxide are absorbed, and in turn, sodium nitrite is formed.